Okay, excellent. So good afternoon again, and thank you for having me present today. As stated before, my name is Tracy Aleong, and I will be presenting on RFID tags used in preventative maintenance program for motors and generators. Also, I would like to thank Professor Kit Phaipoon for his contributions towards the paper and especially his guidance. So for our agenda today, we will touch briefly on the topic and some objectives regarding the paper. We will discuss a little bit about preventative maintenance for motors and generators. That will take us on to condition monitoring parameters such as temperature and vibrations. Before we touch on the RFID technology and its applications, and then we will move on to the RFID system components and touch a little bit on the limitations before we conclude. So, data acquired through condition monitoring can be used to develop a preventative maintenance program for many electrical rotating units, such as motors and generators. Now, condition monitoring is exactly as the name says. You monitor conditions, certain parameters within a device or a piece of equipment, just as we would go to the doctor to get our routine checkups to monitor our heart rates, our movements, our breathing, to make sure that we are working good. We also need to monitor the field equipment that we have installed, especially those mechanical and electrical equipment that have moving parts. To have shutdowns on the field is going to cost us so much more in the long run. So implementing a system that can help us do condition monitoring that will lead to a preventative maintenance program is basically on everybody's wish list. So for our objectives today, we will look at integrating an RFID sensor tag system to create this type of monitoring program for electrical rotating machines and motors. We will cover the basic components of the system that you would require to have the system operating and capable of collecting temperature and vibration readings on both rotary and stationary parts of a machine. Now, this paper was based on the theory part of the design. This is actually a project that I'm working on, and we're going to implement the system soon on a site locally. Because of the COVID, everything was basically on standstill, but this project would have been implemented maybe about 2 months ago. So hopefully I can have that up and running and present another paper with the results later on. Right. So preventative maintenance programs usually help support the reliability and long life operations of motors and generators. As I said before, this involves condition monitoring of your equipment status to trend the performance of the equipment and create awareness of potential issues and failures. However, many organizations lack such a program, especially smaller organizations, because to implement sensing technology on simple things as a motor or a generator, it's going to cost a lot of money because you're using specialized equipment. You're using equipment that requires wireless communication. So you are going to have a high startup cost, and that deters most people. And also it has some complexity in those types of wireless systems. And I know that from my experience working with wireless systems. And these systems usually require some kind of special installation. So all these factors, deter people away. For high temperatures and vibrations are known to be some of the main reasons why electrical rotating equipment expectantly shut down, regardless of the type. When a mass becomes unbalanced, the level of vibration and potentially the thermal signature changes in relation to the imbalance, or changes in relation to the imbalance within the rotating equipment. Overheating is a main reason and it's common reason, and some of the reasons for this is because of overload, poor power conditions, high effective service factors, using it constantly without shutting down, frequent starts and stops, and of course environmental factors. We live in the tropics, we already have a heated environment, so these equipment are going to generate their own amount of heat, added with that heated environment, it's not a good mixture. So, right. So temperature detection is an effective global monitoring technique used for most electrical machines, aiding in the prevention and occurrence of overheating. Excessive heat causes rapid deterioration of insulation windings in induction and synchronous units. A combination of this thermal, electrical, mechanical stress coupled with the environmental stress can cause your windings to age over time. Now, there's a degree rule that applies to motor operating at rated temperature, above rated temperatures, and that is insulation life drops by half every 10 degrees of over temperature. So this is something you really, really want to avoid. Failure is not always immediate, but it can happen at any given time, and that is somebody's nightmare. So machines using permanent magnets, and in those cases, the high temperature can cause loss of magnetization. And magnets that have been demagnetized cannot regain its original magnet strength, even after conditions have normalized. So, mechanical vibration. The vibration of objects in motion is characterized by the amplitude, the intensity, and the frequency. To do vibration analysis, we have to look for abnormalities. So in order to know that, we have to have some kind of baseline for a vibration. And ideally, a baseline is taken new out of the box as you install it. You take that, that signature, that vibration signature, so that afterwards, your trending is always, you have something to reference back towards. Now, in most cases, there are systems that are installed for years upon years. So we can look at, after a motor or a generator has been serviced, taking that point as our baseline if we are looking at an older system. Parts of the rotating equipment that you'd want to monitor, especially your bearings, your gearbox, your rotor parts. These are the areas that will create undesirable conditions that can be identified as unbalance, misalignment, looseness, bearing wear, rubbing, hydraulic problems, electrical problems, and the list goes on. So some rotating equipment manufacturers, they use battery-operated wireless sensors to do testing at the factory. Now, this happens before the item is shipped out. So you're going to have an easy installation process. It's very short-lived, so battery life is not going to pose a problem. And they do this because they want to ensure that their products perform and adhere to specifications. But what happens when you bring it onto the field? Condition monitoring using wireless sensors are not the optimal choice. With frequent battery changes, process interruptions would cost a lot of money, and even that, just having to stop a process and change a battery, those batteries are very expensive as well. And again, that comes from experience. So RFID systems are able to fill the gaps using other systems, using this system. The system would allow for connection of your physical assets to the digital world and have direct effect on companies' business drivers, such as cost savings, greater operational efficiencies, productivity. And I say productivity because if you know that your system is going to fail, you can stop it before it does that and do some preventative maintenance and not be down for months when you can prevent that or plan for that rather. So about RFID. Now, RFID is a form of wireless communication that incorporates the use of electromagnetic or electrostatic coupling in the radio frequency portion of the EM spectrum. Traditionally, it is a technology that has been used for tracking purposes. You would be familiar with RFIDs because to get access to a building, most of those swipe cards use RFID technology. In manufacturing, there are certain points in your manufacturing process that you would have RFID checks to keep track of how your process is going, on-site, inventory management. All these are the typical or traditional uses of RFID technology. And this is similar to barcode technology. Now, in recent time, RFID sensor tag, and this is in the last decade or so, they have given a lot of spotlight to the RFID technology, and researchers and engineers have developed or incorporated the use of smart sensor technology into these little chips. And they are now able to measure process variables such as gas, humidity, temperature, brightness, you name it, all the process conditions that you want to measure, it's now becoming available through RFID sensor tag technology. In our system that we want to implement on site, it will require the basic components, and that would include your RFID sensor tag, which is also commonly called a transponder, and this would be integrated one with a temperature and a temperature sensor, and one that is integrated with a vibration sensor. The RFID reader, which is either available in a handheld mode or a fixed reader, which is when you install it, you leave it right there. And both of them would have an integral antenna. And the last component, the major component, is a compatible PC. And with technology these days, we don't need to have a PC. You can use any smart device down to your phone, because we have that software availability through our smart devices now. And there are some suppliers that provide proprietary software. However, we can keep it as simple as using an Excel sheet to collect the data, and using your in-house specialist or your own experience, use that data that you collected to trend how your device is performing. And just bear in mind, these are for companies that have no systems in place. This is not to replace what bigger or larger organizations may have already installed, but for companies that have no clue as to how their devices are performing on the field. So a very simple system. The tag itself, in its simplest form, is comprised of three parts. Its main part is the microchip, which is the brain box, antenna for collecting signals from your reader, and of course some form of encapsulation. This is just to protect your microchip and your antenna. And as you can see, this is just a typical RFID tag. It's so small, and some of the sensor tags that are available now are as small as a coin. Passive tags have no internal battery because the power is supplied by the reader. This is achieved by the electromagnetic field created by the reader in the reading range, sending a transmission signal. The tag's antenna captures that coupled energy from the EMF and transfers the tag ID and stored information. This coupled energy now is rectified and the voltage multiplied by a multi-stage half-wave rectifier to power up the IC. The sensor tag basically operates in the same manner. It is using the foundation theory of backscattered radio waves to amplify and power itself and be able to sample whatever your process condition, whatever it's meant to be doing. It powers that sensor to do that at that moment and send the information to your reader, and hence the ability to work as a wireless sensor. Now, the reader plays a very important part, because it not only collects the data, but it powers the chip. Now, this chip would be nothing by itself, but a reader in range powers this chip to be able to activate and do what it's meant to do. So a reader can operate between, or emits waves in the ranges of 1 inch to 100 feet or more, depending on the power output and the frequency, the radio frequency that it's meant to work in. There are four ranges right now on the market commonly used, which is the low frequency, high frequency, ultra high frequency, and the micro ultra high frequency ranges. So there are some options available, and it depends on the distance that you want to communicate. You have to select the right read range. Right, the reader decodes the data encoded in the tag's IC, and the data is passed to the host computer or login station for storage and processing. The reader can then be connected directly to a computer, or if you want to have wireless communication, Bluetooth communication is an option. If the reader is mounted as a fixed reader, it must be close enough to sense the tags, and that reader now must be somehow connected to your host computer. And with the availability of the Internet of Things, on your computer, you have access to remote information. So you can share key information to your stakeholders, to your consultants, your specialists, from just as we are doing right now, you know, through the Internet. So in terms of installing these sensor tags onto a motor, you want to, for temperatures and vibration sensor tags, you want to install on different parts of the rotating machine. But the best location has to be considered. So having proper measurement coverage is important, and in order to get effective condition analysis. This figure here, as you can see, there are temperature sensors are distributed around the rotor, and this would allow to give you an idea of a vibration map, or a thermal map rather, of the rotor. And that's what you want. You want to see that picture of the heat that is emanating throughout that piece of equipment. For vibration, we mentioned before that the main areas you want to monitor is like your bearings, your gearbox, and your rotor of the rotating machine. Now, I mentioned in the agenda that we have to talk about limitations. And with all technology, there comes limitation for use. So you have to ask yourself if, you know, this is really going to work for my application, or is it not, is the limitations outweighs the benefits then. So in the case
Tracy,
of our—
if you could just be wrapping it up now.
Oh yes, I just have 2 slides and I'm done. So quickly, the limitations is design and installation. You really have to understand your process application, because again, these things are for monitoring, it's not for control. So if you feel that you need to put it on control, this is not the solution for you. Frequency, based on your read range, frequency is going to be a big factor here. If you use tags that are in a low frequency range, it's not going to read through an ultra high frequency reader. So you have to have the right sets of components. Standardization frequencies, these are all global issues right now. Environmental factor effects, sometimes excessive rain, or even your design of your surroundings can affect the signal. One of the important limitations here is data collision. If you have a lot of tags on the field and you only have one reader, you can have loss of samples sometimes happening if too much information is being sent at the same time. So all these things have to be considered, and you have to work the system and see how best it works for that particular application. So hopefully soon we will have some data on the application that we are going to fill here in Trinidad. In conclusion, RFID technology can fill the gaps of those systems that were from those systems previously used in condition monitoring, including other wireless technology. The basic RFID sensor tag and system components can be used for temperature and vibration of rotating equipment. The use of RFID tags for this application was chosen as the technology is completely autonomous, energy independent, inexpensive, and easy to install. So it makes it a high potential for implementing in parts of the system for preventative maintenance of these systems. So also consideration must be given for the limitation of this using this type of technology. And basically, this is who we are. We are the company that I work for, and we are doing this locally for a few customers at the moment, looking at different process application. We are in the business of tags, basically, so any kind of tags. And this is some of the key references that I use for the paper, so you can check out the paper for full details. And I thank you, and any questions.
Thanks, Tracy, for that interesting presentation. Very good. We're a little short on time, but if there are any questions, well, there's one here. Johnny Chu is asking, since this is mainly targeted to smaller companies, what is the cost of implementation versus something that might be handheld, like a spectrum analyzer for vibration, or a temperature gauge, or even an inline temperature gauge to monitor the temperature?
Okay, well, the tags, just as an average cost, it's about, for a sensor tag, And I've checked a few suppliers. They are around 50 to 80 US for one sensor tag. And a reader is basically the most expensive component, and you just need to buy one reader, and you can use that throughout your facility. You buy as many sensors as you need in terms of monitoring points. So really and truly, when you compare it to a spectrum analyzer, those tend to cost in the thousands. So this system can actually just cost you a couple hundred US dollars just to implement. And then in the initial parts, and then after that, it's just a matter of adding tags where you need to add to get data from.
Thank you very much. So has this system of smart RFID tag monitoring of motor, that electrical motor condition, has this actually been implemented elsewhere?
They have been uses of the sensor tags in different applications, but I've been trying to get data of it implemented in this form, but I was not successful. So hopefully, well, at least locally and within the region, we might be actually publishing a paper of results in this field and then taking it to another level.
Okay, you went a little bit underwater there, but I think we just about got your response that you've been trying to get this to work and you're hoping to publish a paper soon.
Yes.
So
well,
thank you very much. Thanks so much for that present. Yeah, that was great. Appreciate it.